Here's problem 2916. A square loop L equal to 0.2 meters consists of 50 closely wrapped turns, each carrying a current of 0.5 amps. The loop is oriented as shown in a uniform magnetic field of 0.4 Tesla directed in the positive y direction. What is the magnitude of the torque on the loop? It's kind of hard to look at the diagram, but here's the y direction, and this is the z direction, and this is the x direction. We have an angle of 60 degrees here between the plane of the loop and the x direction as we've seen it. So this is a right angle there. And the B field is totally in the y direction, like this. So the B field is going this way. Alright. If we have a current going around this loop, as we're looking at it counterclockwise, then by curling your hand in the direction of that current, your thumb will point in the direction of the area vector that represents that loop. In other words, the area vector is going to be coming out perpendicular to this plane, kind of like this, such that this is a perpendicular angle right there to the plane of that loop. And that would be our area vector. And so, since this angle here is 9 degrees, the angle between the area vector and the x-axis will be 30 degrees. Sounds good. Alright, and the magnitude of that area is going to be L squared, since it's a square, and that's going to be 0.2 meters squared. So that's going to be 0.04 meters squared. That's the magnitude of the area. The angle between the area vector and the x-axis is 30 degrees. The angle between the area vector and the magnetic field then would be, since there's another 30 degrees over here, would be this total angle right here, which is 120 degrees. So there's 120 degrees between the area vector and the magnetic field. So this is how our variables stack up. The number of turns is 50. And the current is 0.5 amps. And the area is 0.04 square meters. The magnetic field is 0.4 Tesla. And the angle between the area vector and the magnetic field we just determined to be 120 degrees. So the torque should be equal to Neab sine theta. Or you might say Bain sine theta if you rearrange it. But this would be the proper form for us. So this would be 50 times 0.5 times the area 0.04 times the magnetic field 0.4 times the sine of 120 degrees. And that is all equal to 0.346 Newton meters. So that is the torque on this loop, 0.346 Newton meters.